Hello friends, you are watching the sixth tutorial of the data analysis using Python series, and in this tutorial we will be exploring the Seaborn library. Seaborn library is a very widely used, very interactive and very good data visualization library, and with the help of Seaborn you can create very interactive and beautiful charts and graphics. So in this tutorial we will be exploring the various graphs that we can build through the library Seaborn. So let's start and build some graphs. So now first of all we will be importing the data and initially we need to import some libraries which we will be needing to import the data set and the other tasks. So first of all we will be importing two libraries, the pandas and the Seaborn. So import pandas as pd and import Seaborn as sns. So these are the two libraries that we will be needing. Now let us also import the OS library and change the directory and change the directory to the desktop where we have the iris dataset. So in this tutorial we will be using the same iris dataset and we will be plotting the various beautiful charts on the iris dataset using the Seaborn package. So now let's change the directory to the home. So C users, okay, oops, I need to change it, users desktop, because the data is on desktop. So now I have changed the directory and now just I need to import the data and we will be doing this by the p.readcsv command and iris.csv, and so let us also print the first few rows of iris dataset. So that is this. So we imported the three libraries, pandas, Seaborn and OS, and then we just loaded the iris dataset, and these are the various variables, the columns of the iris dataset. These four, petal length, sepal length, petal width and sepal width, are the continuous variables, and this spaces, it is the categorical variable. It is the class of the variable. It is the class of the spaces. So now let us see how many types of species are there using the value counts command. Iris dot iris, we need the species. So species dot value counts dot iris species value counts, and then you can see that we have 50 observations for the iris versicolor species, 50 observations for iris virginica, and 49 observations for iris centosa. So these are the three species or three classes of the species column, and now we will just create a joint plot using the Seaborn package. So let us just give a comment over here, the joint plot, and just create to the markdown. And now we will be creating a beautiful joint plot. So sns dot joint plot, and the x variable will be the sepal will be the sepal dot length, and the y variable will be sepal dot width, dot width, the data, we need to give the argument data is equal to iris. Oh shit, iris, and let us keep the size is equal to 5 of the graph. Let us keep the size is equal to 5. So now we are going to create a joint plot with the x and y variables, and the data is iris, and this we have kept the size is equal to 5. And now let's create the chart. Oops, so we forgot to insert a command for matplotlib in line to output the graphics in the same cell. So let us first run it, and then we will run it. And now here you can see the beautiful joint plot with an histogram for the sepal length over here, this axis, and for the sepal width, this axis. So, and you can see that it is also describing some statistics like the Pearson-R coefficient and the p-value. The Pearson-R coefficient denotes that there is a negative correlation between these two variables. There is a negative correlation, Pearson-R coefficient of minus 0.35, and the p-value is also 1e, that is 0.00005. Yeah, so this is the p-value and Pearson-R value, and we can see that this is the beautiful joint plot we have created. So let us now again one more joint plot, and let us see what is the relation between petal length and petal width. So we will again create a joint plot for x is equal to petal dot length and y is equal to petal dot width. Now the data is equal to iris. We again need to define this. The data is equal to iris, and the size, let's keep the size to 5. So now we are going to create a joint plot between petal length and petal width. So now here we can see that the correlation, the Pearson-R coefficient between the petal length and petal width is 0.87, which is quite higher. So we can see that with increasing petal length, the petal width are also increasing, and we can also see the beautiful histogram over here. So that is why it is called the joint plot, and it is very beautiful. So let us now change the size. Let's change it to 10. Here you can see this. We have changed the size, and you can see it more. Let's keep the size to be 5 again. It's quite big. So we have just created the joint plots using the Seaborn package. Now in the next step we will be creating the facet grid plots. So using the Seaborn package, facet grid plots, and let us create a markdown. Facet grid plots. Now we will be just creating a facet grid plot, and we just need to provide the following arguments, like iris is the data set, that is the class, is equal to variable species, and size is equal to 5. Now so let us see what it creates. Okay, it haven't given the anything, and we just need to create the data frame, and we will just dot map plt dot scatter, sample length and sample width. Sample dot length comma sample dot width. Now again we need to just give it dot map dot add legend so now let's create. Okay, it is showing the error, and just Google something. I need to Google something. Backward slash was missing this parameter, and I will be needing it. So I'll be needing it. So this is the thing that we wanted, and now you can see we are committing some mistake anywhere, and let us see where is the mistake. PLT is not defined. PLT dot scatter. PLT is not defined. Okay, so we are doing a mistake over here, and we need to import matplotlib dot py plot as PLT. So now we have fixed it, and there you can see it. The graph is there, but it is saying that there is no argument which has the name add legend. Okay, again we are doing a mistake over here, and now you can see this. We fixed the code, and that is this. We just forgot to import the matplotlib.pyplot, and we just did the mistake over here. We just spelling mistake, syntax error, and now this is the facet grid plot, and you can see that we just created a facet grid plot, that is a scatter plot between sample length and sample width, and we just also created the colors, the facet grids on the basis of color. So this is the very beautiful graph that we have just produced with the help of Seaborn and facet grid plot. So now we will be creating a box plot. And with Seaborn, with the following command, SNS.boxplot, and we will be just giving the x variable to be spaces and y variable to be pattern dot length, and data we need to also show the data to be iris. Now we are just going to create a box plot, and let's see how it looks like. So this is the box plot. You can see that how beautiful it looks like. You can see how beautiful it is. We have created a box plot between the petal length, and this is the petal length. Average is 5.0 for iris and tosa. For versicolor it is between 5.8 or 5.9 something, and for virginica it is around 6.5 to 6.6. So you can see that we have just created a beautiful box plot using the Seaborn package. And now finally we can also create a more interactive box plot by changing some more things, like we can define it to be ax, and just we will try to copy it here. Axis, we will just import some jitter and edge color in it, and we will just try to strip the plot. So we will be using the strip plot function of Seaborn package. So let's just do it. So now again ax is equal to SNS dot strip plot, strip plot, and you just need to give the same command again, and also the zitter is equal to true and edge color to be gray. Edge color to be gray. Now let's see what happens. So now you can see that we have changed the, we have shown the distribution and how these things are changing, and that you can see that it is more interactive plot as compared to this one. You can also see here the data points, the different varieties, the different classes being listed over here. So this is, we have created a zitter. If we haven't given the zitter, then it would have shown a simple line data points, but now it is showing the differentiated data points. So this is the importance of using strip plot. And now we will be creating a Boolean plot. So now to create a Boolean plot, we will be using the SNS dot Boolean plot command, and we will be creating x is equal to species, y is equal to petal, dot length. Okay, length. Yeah. So we have created the x and y variable, and we just want to say that the data is iris, please take it, and the size, please keep it to be 6 or 5, whatever you want. 6. So now we will create a Boolean plot. So this is the Boolean plot. You can see that it is quite interesting, and you can see that it is changing, the size of it is changing with the quantiles. You can see that here the minimum data length, minimum petal length is there for Iris virginica, and the maximum is here. And you can see that here is the maximum number of data points over here, and this represents the mean, the average value. So you can see that it is more interactive than this one as well. So this is the reason of using Boolean plot. And again, and one more very most importantly used plot is the pair plot package. It is the pair plot function of Seaborn package. So we will be just creating a pair plot. It is just for exploratory data analysis, and where you can compare or visualize the all variables of the data set all together. So then we need to create the pair plot. We will be just creating a pair plot for the data. It takes all of the data at one time and creates a beautiful plot. Let us say that we want to create a scatter plot. Scatter. Yeah. So this, here we will be creating a pair plot. So here you can see that this is a pair plot that we have just created with the help of pair plot, sns.pairplot function. And you can see that the on the y-axis and on the x-axis as well, there are all the columns all together, and you can see that this is the scatter plot between sepal width and petal length. This is the scatter plot between sepal width and sepal length, and this is the histogram of sepal width. This is the histogram of petal width. So this is the very important function of Seaborn package. You can just visualize the whole of the data set all together. It is most widely used command in Seaborn package. So this was the the tutorial on Seaborn package, and we just see that first of all we just loaded the required libraries and the data set, and then we just try to see how many different classes the counts are there, and then we just created a beautiful joint plot. You can see it over here, and then we created a facet grid plot, and then we created a box plot, and then we created a volume plot, and then we created a pair plot. So these are the various beautiful plots that we created with the help of Seaborn. I hope you enjoyed the video, so please like and subscribe, and thanks for watching.